Okay, picking up where we left off. So when we find this other angle, which would be the inverse tan of 4 over 3, it's going to end up being 53.13 degrees. Which way are you going first? North, so north goes in here first, and then which way did you turn? East, so east goes here. Okay, and so then that is the answer to if you move the 4 Newton east up. Does it matter to me which one you do? Nope, because they are both 100% correct. Okay, they're exactly the same thing. So that's case number 3, adding vectors that are at right angle. The fun one is case number 4, because case number 4 is any other angle. So it stops being perhaps common sense now. Okay, so case 4, any other angle. All right, so this time I have my 4 newtons still going east, but now you are going to push at an angle. You're going to push like this, 3 newtons, and let's make this angle maybe 30 degrees. Okay, so again, I need to slide it head to tail before I can add it together. So my 3 newtons is going to be here, and this angle here is going to be 30 degrees. Okay, and this is my 3 newtons. So my resultant will still start where the first one started and end where the last one ended. My markers have 2 different tips. That was the thick tip, even though I didn't want it. And so there are 2 ways that we can find this. One way is to break this 30 newtons into its components. Remember that? We would call the one going in the x direction x and the one going in the y direction y. And we have our hypotenuse, which is 3 newtons, so then we could find the 2 sides. We could say, well, y is the opposite side, so I have the opposite in the hypotenuse, so I could do sine of 30 is equal to y over 3 newtons. So y will be equal to 3 newtons times the sine of 30. The sine of 30 is just 0.5, so y equals 1.5 newtons. And so here I could put 1.5 newtons. And then I could say, okay, x is the adjacent side, so that will be cosine. So the cosine of 30 will equal to x over 3 newtons. So x will be equal to 3 newtons times the cos of 30. The cos of 30 is 0.866 times 3. What do you do when you're doing this stuff and don't have a calculator? 866 times 3, so 2.598, I think. 2.598, but I'm kind of guessing there. If I'm wrong, I apologize. And so that would be here. I'm not sure about those decimals because there's only so many decimals you can do in your head. And so then what happens? Well, then what happens is you could take white out, because once you found the legs or the components of the dude going at an angle, it's like that dude isn't there anymore. And so now you just have a right angle triangle, right, whose base is 6.598 newtons and whose height is 1.5. And so now you can square them, add them together, find the square root, and get your resultant and get this angle. So that's one way, and I'm not going to do all that because, did I just mention, I don't have a calculator within reach of me, and so you can do that. Okay, I know you can do the Pythagorean. There is another way you could have done this, so I'm just going to redraw here. So here is my 4 newtons going east, and here was my 3 newtons at 30 degrees, and here was my resultant. Imagine that straight, would you? The other way, which we wouldn't have done in grade 11 physics because you hadn't learnt it then, but you know it now, the other way is the sine law or the cosine law, right? Because if this is 30, then this is 150. And so you could find this by, you have a side, an included angle, and a side. So the sine law is a over sine A oh, I think you probably called this a little a, is equal to b over sine b, or you could write it the other way around. Everybody remembers the sine law. The cosine law is the one that's harder for people to remember. The cosine law is c squared is equal to a squared plus b squared. That shouldn't be too tough. That kind of looks like the Pythagorean theorem. Minus 2ab cos c. So the way I usually tell people to remember it is, it's the Pythagorean theorem, except this isn't quite a right angle triangle. It's missing a part, so you have to take a part off. So it's minus. What's it missing? Well, you have two sides, so 2ab, and it is a cosine law, so it'd be good if we had a cosine in there somewhere. Okay? So this is the cosine law. Now the question is, which one do you use? And the answer is, for sine law, you have to have a side and its opposite angle. So we have a side, but the opposite angle would be up here, and we don't know it. We have a side 3 newtons, the opposite angle will be down here, and we don't know it. We have an angle, the opposite side would be over here, we don't know it. We cannot use the sine law. You have to use the cosine law, which you always use when you have two sides and the included angle. So you could find then this, the c would be r here, and then once you found that, you could use the sine law to find the angle. Okay, and you should get exactly the same answer as up here. Okay, so we're not going to do that right now. I just wanted to remind you from grade 11 of the 4 cases, and in physics 12 we'll do this a fair bit. But in science 12.2 we won't be adding vectors together as much as we'll be multiplying them, but you can't multiply if you don't know how to add, so I needed to go back to that. But first, so all of this is adding vectors is number 1. Okay? Before we get to multiplying, I do need to talk to you about a couple of other things, and one of them is something that's called absolute value. I believe you have done absolute value in math. Okay? If you were in front of me, I would say to you, so what is the absolute value? Back when you were little, like maybe in elementary school or somewhere, you probably found the absolute value of a number line. I don't know, I think it was, I learned it in elementary. You might have learned it last year, who knows. So we have 1, 2, 3, 4, and then on this side, minus 1, minus 2, minus 3, minus 4. Now in reality, if you did this in elementary school, they probably didn't tell you it was the absolute value. But they probably put a dot like here and asked you how far was it from the origin, and hopefully you said 3. And they probably put a dot over here, imagine that line is straight, would you, and asked you how far it was from the origin, and hopefully you said 4. Really what you're doing there is you're finding the absolute value, because that's all the absolute value is. It's the distance from the origin. Okay? Distance from origin. It's how far it is away from the starting point, not what direction. That's why we don't care about the negative. Okay? So here you might, like, that's why we have like the absolute value of -4 is equal to 4, because we're just getting the distance, how far it is from the origin, not what direction it is. Okay? Now for a vector then, if we were to talk about a vector, really then the absolute value of a vector is just its length. The length of a vector. Not what direction it's going in, just how long that shaft was. Remember earlier I had said this shaft is the length of the vector. So absolute value then is just the length of the shaft or the length of the vector. So in one dimension then, that's easy, just find its length. But what if we go to 2 dimension? So here's my 2, and I'm going to run out of time. Man, that 10 minutes went fast. So imagine my vector was here. Well, how do we find its length? Well, you could figure out its components, its legs. You could realize, oh, this comes down to 4, and this goes up to 3. And so this dot here would be at 4, 3. And what would you do to find the length? Well, you would realize, yeah, it has 2 components, a component here and a component here. And what can you do to find the length? It's the Pythagorean theorem. So every time you've done the Pythagorean theorem, really what you've been doing is finding the absolute value of the vector.